In this problem, we have an L-shaped bar. The L-shaped bar is rotating about a vertical axis, the z-axis, which is passing through end O of the bar. It's rotating, as we look at it from the top, in a counterclockwise sense, with a speed of 2 radians per second. But that rate is decreasing such that the angular acceleration vector is in the minus k direction with a magnitude of 3 radians per second. Out there on the other end of the L-shaped bar is this peg P, and what we want to do is find out what the acceleration at point P is, knowing the rotation rates and angular acceleration of the bar as it rotates about O. So let's write down the things that we know about the problem. Well, the angular acceleration the angular velocity of the bar is, again, its speed is 2. It's rotating about the k-axis. As we look at it from the top, it's in the counterclockwise sense, so by the right-hand rule, it's a positive k radians per second. The angular acceleration of the bar, it has a magnitude of 3. It's rotating about the k-axis, but it's in the minus k as you look at the picture by the right-hand rule, so this is in radians per second squared. I'm going to use an acceleration equation which is referenced back to point O. So I'm going to need the vector which goes from O to P. So as I go from O to P, if I write that out in meters, it's 0.5 in the x, it's 0.25 in the j, and it's 0.05 in the k. Again, this is in meters. Okay, so let's do the velocity part first. Velocity of P, using the rigid body equation referenced back to point O, is equal to VO plus the omega vector crossed with the vector which goes from O to P. O is the axis of rotation, so VO is a 0. Above we see omega is 2k, and this is crossed with the vector which goes from O to P. Write that down again. That's just 0.5i plus 0.25j plus 0.05k. So as I carry through my cross products, I see I have a k cross I, which is going to give me a j. 2 times a half is 1, so there's going to be a j there. The k cross j gives me a minus I, and if I multiply the 0.25 times 2, that gives me a 0.05, so this is minus 0.5 I. And k cross k is a 0. So the velocity of P then is that vector in meters per second. The acceleration equation, that will also be referenced back to point O. So AP is equal to AO plus alpha crossed RP with respect to O plus omega cross RP with respect to O. O is on the axis of rotation, so AO is a 0. Alpha we saw is a minus 3k. That gets crossed with the R vector that I wrote down above, so that's 0.5i plus 0.25j plus 0.05k. Like that. I need to cross omega, which we saw was 2k, with omega cross r. We've already got the omega cross r from here, so I'm just going to write down that result, minus 0.5 I plus j, like that. Okay, so I need to cross my alpha with the r, so the k cross I gives me a j, so that's a minus 1.5j. K cross j gives me a minus I. There's already a minus sign, so it now is a plus 0.75I. K cross I, that's a J, already a minus sign in front, so there's going to be a minus J term there. There's K cross J, which is a minus I, so that's going to be a minus 2I like this. Okay, so I grouped together my terms. The I components are going to give me a minus 1.25 in the I. The J components are going to give me a minus 2.5, and of course that's in meters per second squared, like that. So what we did was just do a very basic implementation of a rigid body velocity and acceleration equation. Both of those were referenced back to point O. Point O is a good choice because O is a stationary point on that shaft, and so that simplifies the analysis some. One thing to note though, let me write down an alternate form of the equation we have and will continue to use this semester, is the acceleration equation written in this form. Compare that with the one that I actually used right here. And one thing that we talk about in class is that this form of the equation is easier to use, but it only works if O and P are both in the XY plane. And that's most of the problems we're going to do, that's going to be the case. But note that this problem is a little bit different in that P is raised up by this distance of 50 millimeters up above the XY axis. In that case, we need to use this full form right here. So be careful. Whenever you use the more simplified form of the equation here, where you have the minus omega squared r, that's only valid if O and P lie in the same XY plane.